Hi, kids of Ms. McCleskey's class. It's Mike again. I want to tell you a little bit more about statistics. Today, we're going to talk about this really cool kind of graph called a box plot. So here's what a box plot looks like. And I'm going to show you how to make one. But first, a little history lesson. So I'm going to share my screen with you for just a second. This is a man named John Tukey, and he invented the box plot. And he was born in about 1915, born in Massachusetts, and he was a famous American statistician. He died in the year 2000, so he died before any of you guys were born. But that's the man who invented what I'm going to show you how to do today. Okay, so in order to do a box plot, what we need is a bunch of data. And I collected some data the other day from, you remember when I scooped through that little trough of balls and I would count how many white ones there were. Well, I got about 30 data points when I did that, but I needed more data. I wanted a little bit more data to make a box plot. The more data you have, the better in making a box plot. Now, I know a lot of you probably haven't collected a ton of data, and that's okay. You can still make a box plot. But if you have a lot of data, it usually looks a lot better. So I created some data. Let me show it to you. I'll share my screen again. Here's what my data look like right here. So I've got a bunch of numbers. I don't know, I'm looking through there, kind of trying to get a feel for what these numbers look like. I can see some as low 50s. I can see some as high as the low 70s. So what I've done is I've created a scale. And so let me stop sharing. I've created a scale. It's kind of crooked. Sorry, I didn't draw it very straight. But can you see it along the bottom of that page? Starts at about a 45 down at this end and goes up to about 75 down on the right end. So I'm going to use this scale to create my box plot. Okay, so let's go back to my data. Go back to sharing again. I'm going to just talk you through this for just a second. I'm using a program called Excel to look at my data because Excel has some great properties being able to manipulate data. Okay, I've got A, B, C, D, E, F, G, H. I've got 8 columns of data, and each column has about 14 rows. So 14 times 8 is 112. I've got 112 different data points. Well, I need to come up with, there's this thing called the 5-number summary anytime you have a set of data. The 5-number summary is the minimum value. We kind of talked about that before. The median value, which we did talk about before, and I showed you how to calculate, and the maximum value, which is also, we've kind of talked about it a little bit before, but it should be pretty obvious what that is. So those are 3 of the 5 numbers in the 5-number summary. The other 2 we haven't talked about yet. And I don't know if they're really a part of your curriculum or not, but I want to tell you about them. One is called the first quartile, and the other one is called the third quartile. So the 5-number summary actually in order is from smallest to largest, it's minimum, first quartile, median, third quartile, and maximum. Okay, so how do I figure those things out? Well, if I've got a spreadsheet like Excel, it's really easy to do. If not, I have to kind of rearrange my numbers. Remember when we did the median the other day, we would order the numbers from smallest to largest and then go either pick the middle number if we had an odd size set, an odd number set size, or if I had an even number set size, I would take the 2 middle values and do the average of those 2. Well, we're going to do the same thing here. So in this other spreadsheet, I've taken those same numbers and I've arranged them in a single column here. So I've got 112 different entries. Okay, I'm going to take this column and I'm going to actually sort it from smallest to largest. So just stick column A in there, sort it from smallest to largest. And now you can see how they're all sorted. So I got 50, a bunch of 51s, 52, 53, 54, all the way up as I scroll down to 71. Okay, so what do I need to know? I need to know my minimum. And that is obviously 50 because it's the very first value when I've got them sorted from smallest to largest. I need to know the first quartile. I need to know the median. I need to know the third quartile, and I need to know the maximum. Okay, let's do the easy ones first. Let's we got the minimum already. Let's go down and find the maximum. Maybe you remember what it was from just a second ago. Maximum is 71. So I'm going to put that in right here. And I'm not going to actually create the box plot in Excel. I'm going to draw it by hand, but I just want to capture these numbers. Okay, the median. I have 112 data points. And remember, the median is the point at which half the data are larger and half the data are smaller. So half of 112 is 56, and I've got an even number of data points here. So I'm going to go to row 56 and 57 and see what those two values are, because my median will be between those two values. You can see that they're both the same. So in this case, that's going to be my median. If they were different, if they were like 61 and 63, for instance, I would take the average of those two values and I would say 62 would be my median. But since they're both the same number, that was pretty easy. Okay, first quartile and third quartile. What are they? Well, just like the median is the point at which half the data are smaller and half are larger, the first quartile is the point at which 1/4 of the data are smaller and 3/4 are larger. And then the third quartile is the point at which 3/4 of the data are smaller and 1/4 of the data are larger. Okay, so if we've got 112 data points, and I'll just do the math in my head real quick. If I took 112 and divided by 4, that would be 28 in each quarter. So if I take the 28th row and the 29th row, we've got 28 and 29. So the value between those two values is going to be the first quartile, because that's the point at which 28 rows of data are smaller than that number. And let's see, 28, 56, 84. 84 rows of data are larger than that number. Again, they're both the same number. So I'm just going to call it 55. And I'm going to do the same thing once again with the third quartile. So if 3/4 of 112 is 84 rows, so if I go between row 84 and 85, that would be my third quartile. They're the same number once again. So I know my third quartile is 67. Okay. So now I need to look at these numbers. I'm going to stop sharing because I want to show you how I'm going to create my box plot. All right, so we're back to this piece of paper right here. First thing I'm going to do is I'm going to draw in the median, and I'm going to use a pretty tall line. So my median was 61. I'm going to use red so it stands out really good. Okay, so I'm going to make it kind of thick. Okay, so you can see how I plotted my, just kind of guessed where it would be. But looking at the graph, it looks like it's about in the right place. Okay, that's my median, that's 61. Now I'm going to do my min and my max. My min was 50 and my max was 71. So I'm going to go horizontally even with that first mark I drew, and I'm going to draw a smaller mark at 50, and I'm going to draw another small mark at 71. Okay, so now I've got my minimum at 50. I've still got my median at 61. I've got my maximum at 71. Okay, now I've got to go do the first quartile and the third quartile. That's 55 and 67. So I'm going to draw a mark that's not as big as the median, but not as small as the minimum and maximum. I'm going to draw it at 55. I can't remember what the other number was. 67. Okay, now I've got those 5 marks on my paper. Can you see how the middle one's the tallest one, and these two next to the middle are a little bit shorter, than the ones on the end are really small. Okay, now all I got to do is draw a box. So I'm going to connect the first quartile and the third quartile and have it go right through the median. And then I'm going to draw just a single line that goes, whoops, that's kind of crooked. Not very straight. Anyway, I drew those end lines that go from this one goes from the first quartile out to the minimum, and this one goes from the third quartile out to the maximum. Those are often called whiskers. In fact, quite often you'll hear people call this a box and whisker plot, but the real name is a box plot. And again, we've got John Tukey to thank for creating this for us. So that's a really good way with a very simple drawing to show where the data are. And it's called the Boxplot. So have fun making Boxplots, and we'll see you tomorrow. Thanks, guys. Bye.